Today's lesson is the last lesson of chapter 4, and we will be looking at our second day of solving rational equations. Before we start, I want to make sure you review what we did yesterday. So I want you to take a second and try this warm-up to find the solutions to the rational equations 1 over x minus 1 over 5x squared equals 1 over x squared. So pause the video, try it, and then check your answer. So this one was actually a little bit harder than some of the ones we did yesterday because the LCD was a combination of actually all three. So you had to recognize that the least common denominator was 5x squared. When I multiplied each fraction by the 5x squared, you'll see that I wrote that 5x squared on top of each one. And then I canceled and simplified in each fraction. So in the first one, just 1x canceled, so I was left with 5x minus. In the second one, the x squared canceled, so I was left with 5. And in the third fraction on the right-hand side, I also was able to just cancel the x squared, so I was left with 5. Once I got there, I added 5 to both sides, got 5x equals 10, and finally divided by 5 to get x equals 2. Okay, so that's a review of what we did yesterday. We're doing that same thing today, but we have to add in another interesting situation that comes up every once in a while. Whenever you're doing this process of eliminating the denominators or clearing the fractions, you are taking an equation and you are getting rid of things that are actually very important. So it's good in the sense that it helps us solve, but it's bad in the sense that you're like making things disappear. And anytime you do something weird like that in math, you have to check for this thing called an extraneous solution. An extraneous solution is an answer that you actually get when you're solving, but it wouldn't work in the original problem. And the reason it wouldn't work in the original problem, if we're talking about these rational equations, is because it would make the denominator 0. Okay? So an extraneous solution is a solution that you get that makes the value of the denominator in the original equation equal to 0. Okay, so for example, if I look at this first problem, 1 over x minus 5 plus x over x minus 3 equals 2 over x squared minus 8x plus 15. If I get 5 as an answer, if I plug 5 in here, I would get 5 minus 5, which equals 0. Well, then I'm doing 1 divided by 0, which is undefined, so that couldn't be an answer. Similarly, if I got 3 minus 3 is 0. I'd be dividing by 0, and I can't do that. So when we're still going to solve the same way, but when we get our final answers, now we're adding in the step where we're going to check to make sure those answers are okay. All right. So now when we go to do these problems, the first step is still to find the least common denominator. In order to do that, though, step 1 is actually to factor all of the denominators. Because sometimes in these problems, you're going to see like what we see on the right-hand side where that's not factored. So I'm going to rewrite it with all three denominators factored. The first two are okay. But then the last fraction, x squared minus 8x minus 15, two numbers that multiply to 15 and add to negative 8, are x minus 5 and x minus 3. Okay, so negative 5 and negative 3. So when that a is 1, again, that's my easiest case scenario. All right, once they're all factored, then you're going to find the LCD and multiply both sides by it. Okay, so in this case, my LCD is x minus 5, x minus 3. Then when I get to the other side, those are all already there, so I'm good. Okay, so also in that step, then I'm going to take each side and multiply by it. So we talked yesterday a little bit about how as you continue to practice, you might write less steps, meaning you might not need to show this next step fully. What I'm going to do though is I am going to rewrite each fraction, multiplying that numerator by that common denominator. So I take the 1 times both factors and over x minus 5 plus x, this numerator times that, x minus 5 times x minus 3. That one was over x minus 3. And then finally the right side, 2 times x minus 5 times x minus 3 over its denominator, which is x minus 5 times x minus 3. Okay, so then once we do that, we're going to simplify each fraction just like we did yesterday. Okay, so now these cancel, and actually both of these cancel. And then once I do that, I'm going to solve for x. Okay, so this clears the fraction, remember. If it doesn't clear fractions, then you made a mistake. All right, so on top of this one, I have 1 times x minus 3, so the 1 doesn't matter, so I just have x minus 3, plus this one, I have x times x minus 5 equals 2. Now I simplify. X minus 3 plus x squared minus 5x equals 2. Combine like terms, I get x squared minus 4x minus 3 equals 2. And then I would subtract 2 from both sides. So I get x squared minus 4x minus 5 equals 0. Okay, so I'm still solving for x. I have a quadratic, so I need to factor it. That does factor as x minus 5 times x plus 1 equals 0. And then remember, when we have factors, we take each factor, set it equal to 0, or set them equal to 0, and solve for x. So x equals 5, x equals negative 1. Here's the added step though. Number 5, you're going to check for extraneous solutions. So that's really the only new step today. And we'll be doing a little bit more challenging problems. So check for extraneous solutions, which means, again, if I plug 5 back into this original problem, okay, so I gotta erase this. Remember, if I plug 5 in here, I'm dividing by 0, so that makes it undefined. So 5 is an extraneous solution. I got an answer of negative 1. I checked that. I could plug that, and that's okay. So x equals negative 1 is my only solution. X equals 5 is an extraneous solution. So the way this will work on Pearson is it'll give you an option in multiple choice of a real solution and an extraneous solution. So you'll want to make sure you pick that one, and then you'd put the negative 1 in the box that says the solution and the 5 in the box where it says extraneous solution. Okay. All right, let's try another one. So what are the solutions? Again, I start by finding the LCD. Everything's factored in the denominator. My LCD here, it looks like it's just the x minus 2. So then I multiply both sides by x minus 2. This first one, I would get 5x times x minus 2 over x minus 2 equals 7 times x minus 2 plus 10 times x minus 2 over x minus 2. Okay, once I find the LCD and multiply everything by it, then I simplify each fraction. These cancel out in both of those fractions. On the left, I'm left with 5x. I'm going to distribute here. I get equals 7x minus 14. And then this only has the plus 10 left. So I have 5x equals 7x minus 4. Subtract 7x. Negative 2x equals negative 4, and divide by negative 2. So my x equals 2. Okay, so more simple maybe than the last one because we only had one piece in my LCD and I did not end up with a quadratic I had to factor. However, be careful because sometimes when people only get one answer, they're like, oh, it must work. There's only one. But remember, if I check this back in the original, if I plug my positive 2 in for this x, like I got, I am dividing by 0, which means I can't do it. Which means the only solution that I got, 2, is an extraneous solution. If the only answer you get is an extraneous solution, then your actual answer is no solutions. Okay, so again, back to your answers on Pearson. It will give you a multiple choice option that says no solutions. And so if you get only an extraneous answer, you want to make sure that you pick the no solutions option. Okay, let's do one more example together. If you're feeling good about it, though, you could pause it and try it. But otherwise, in just a second, I'll give you an opportunity to try a couple. Okay, so my LCD here, I have a 4 and an x minus 3. So my LCD is 4 times x minus 3. I multiply both sides by 4 times x minus 3. Again, when I distribute that, I am going to write it as 3 times 4 for right now. Obviously, I'll simplify that in a second. Equals x times 4 times x minus 3, x minus 3, minus x times 4 times x minus 3, all over 4. Okay, so I like to write it out like that. It just gives me a visual. Again, as you keep progressing, you'll write less and less. So this cancels. I get 12. These cancel. I'm left with the x times 4, which is 4x. And the 4's cancel, so I'm left with minus x times x minus 3. Now we simplify. 12 equals 4x. Make sure you distribute the negative with the x. So negative x times x is negative x squared. Negative x times negative 3 is positive 3x. Now when I combine like terms on the right, I get negative x squared plus 7x. Now here's where you want to be careful. I do need to set it equal to 0 so that I can factor and solve since I have a quadratic. But in order to do that, we have to remember that if I'm going to factor, it's harder to factor if my a is negative. So I'm going to move both these pieces to the other side to keep my a negative. Okay, so I changed it to x squared minus 7x plus 12 equals 0. Now I'm able to factor this. It's x minus 3 times x minus 4 equals 0. And then I take each factor, set it equal to 0, and solve. Again, this would be another step you're probably not showing as much anymore, which is okay. Oh, that's not a 4. That would be 3. Thinking ahead. And this one would be 4. Okay? So again, I have two answers, but my last step, this is the new piece, I have to plug them back in. So if I plug 3 back into my original, I would get 3 minus 3 in the denominator, which is 0. So 3 is an extraneous solution. Okay? 4, I have to check that. 4 minus 3, that's okay. So my solution is x equals 4. My extraneous solution is x equals 3. So I would be looking for the answer on Pearson that has the blank or the multiple choice that has both a solution and an extraneous solution. All right, now that we've done a few examples together, I want you to pause the video and I want you to try both of these problems. Okay, so it should take you a few minutes. Take your time, and then when you have your solutions and your work, come back and check your answers. Hopefully for the first one, you got that there's no solutions. Now my work is incredibly messy. I apologize for that. I didn't give myself enough space. But the top one, you should have multiplied both sides by x plus 2 times x minus 2. When you did that, the first fraction became just x minus 2. The second one became plus x plus 2 and then equals 4. Okay, so I had x minus 2 plus x plus 2 equals 4. The negative 2 and 2 cancels. So I had an x plus x, so 2x equals 4. And then when I divided, I got x equals 2. But if I plug 2 in for this x, right, I would have 2 minus 2, which is 0, which means I'd be dividing by 0, which is undefined. So that's an extraneous solution, which means it doesn't exist, so there's no solutions. Okay? In the second one, the least common denominator was just x minus 3, so you should have multiplied both sides by x minus 3. So my first piece just becomes x times x minus 3. In the second one, the x minus 3 is canceled, so I'm left with just a plus 6. And same thing in the third fraction. The x minus 3 is canceled. I'm left with 2x. When I distribute that first piece, I got x squared minus 3x plus 6 equals 2x. So my only thing I had to do was subtract the 2x to the left. So I had x squared minus 5x plus 6 equals 0, factored as x minus 3 times, or x minus 2 times x minus 3 equals 0. So I got solutions as a starting point of 2 and 3. But again, when I plug in 2, that would work, but when I plug in 3, it would make the denominator 0, so that's the extraneous solution. So we're going to skip the word problem, actually, and so that is all that we have for today. You will have one word problem on your homework tonight, but it was less complex than that one I just skipped over. So it's more similar to the one I showed in the first video, but I think if you really think about what they're saying is happening in both situations, you should be okay. And then if you have a problem with the word problem, just make sure you click on the help button in that Pearson problem. Okay, so here's the summary. Talks about the different things that we need to look at when we are solving rational equations, but that's what we've covered the last couple days. Just don't forget from today's lesson to check for that extraneous solution because we can't divide by 0. You can now go ahead and work on your 4-5 day 2 Pearson practice, and good job with chapter 4. Thanks.